All right, so for 26, let's first find the inverse. So we'll switch our x and our y. Y plus 6 over 11. Now we need to solve for y, so let's multiply both sides by the denominator. And it cancels out here. So I have y plus 6 is equal to 11 times x. And then my last step is I subtract 6 from each side, so I get y equals 11x minus 6. So up at the top over here, I will put the inverse, that's how I write it, of x should be 11x minus 6. Now I just need to prove it. So let's erase this. Whoops. And yeah, forgot some. And this, and we'll prove it. First we will do f of f inverse of x. So I will rewrite f of x, but everywhere I have an x, I'm going to leave a big space. So I'm going to have x plus 6, that whole entire expression over 11. And then on the inside, I'm going to put 11x minus 6, my entire inverse. Minus 6. Okay, now since we are not on the numerator, everything on the numerator has to happen first. Since we are not multiplying 11x minus 6 by anything, we're just adding 6 on at the end. Since we're not multiplying, I can get rid of my parentheses. Okay, I don't need them because I don't need to distribute anything. Once you get rid of your parentheses, you realize the negative 6 and the positive 6 cancel out because that's 0. And then once you get rid of those, you realize you have 11 over 11, which is just 1. So that whole expression simplifies down to just x. So one way works. Do we have to do it both ways to prove it? We actually do have to do it both ways to prove it. So we need to do the inverse of f of x, the inverse of f of x. And that's going to be equal to, now I write down the inverse, which is 11x, but instead of x, I leave a whole empty spot, minus 6. And then on the inside, I put the original equation, which is x plus 6 over 11. Now, since I have to distribute this 11, but x plus 6 is all on the numerator and 11 is on the denominator, when I distribute, all that happens is those cancel, and all I have is x plus 6, and then we still have minus 6 on the outside. Positive 6 and negative 6 cancel out, and they are in fact inverses because f inverse, f of x, is also x. All right, so the application piece, you guys, is just, so Mr. Writer gave us the applicable information up here. So here's the formula you're going to have on the test. It'll give it to you. And here's where all the pieces need to go. P is the initial value, A is the outcome, R is the interest rate, and T is time in years. So for the first one, 850 is invested. That's our principal, or our P, which is our initial investment, our principal investment. That's what the P stands for. Our interest rate is 5%, so we're going to write that as 0.05 is our interest rate. And our A, or our expected outcome that we want, is $5,000. We are trying to figure out how long it's going to take if we put $850 into this account for us to get $5,000 back. So our actual equation that we need to solve is going to be $5,000 is equal to 850 times 1 plus, that 1's important or else it's going to get smaller, 0.05 to the power of t. And since we want to solve t, we want to solve for an exponent, and our exponent is the variable, we're going to have to use logs. But before we get to the logs, we can divide both sides by 850. So 500 divided by 85, let's see here. Oops. $5.88 approximately. And I'm going to go ahead and change this to be 1.05. And let's take the log of both sides. And I'm going to do 2 steps at once, you guys. I'm going to say this is equal to t times the log of 1.05, which is just a number. So we just have divide both sides by the log of 1.05 to figure out approximately, remember these should all be approximately now, approximately, this should have been 5.88, approximately log of 5.88. I will call you out by name if you keep doing that. Divided by the log of 1.05. Approximately 36.3 years. If you originally invest $850, don't add any more money, it'll take you approximately 36.3 years to reach $5,000. All right, you guys, I'm not going to completely do this one for you, but I'll help you set them up. Our principal interest is $250 for number 30. Our rate of interest is 0.032. And then it wants 3 different answers. It wants how long will it take to have $750? It wants how long will it take to be $985? And it wants how long will it take to be $24,582. So I will just help you write 3 equations that you should be able to solve. And I will give you the answers so that you can check yourself. Hold on. So the first equation is going to be 750 is equal to 250 times 1.032 to the power of t. The second equation is going to be exactly the same, except our outcome, our output is going to be 985.32, but everything else is going to be the same. And our third equation is going to be 24,582.6 is equal to 250 times 1.032 to the t power. The answer, all right, the answer for how long it will take to be $750 is approximately 38.88 years. Oh, sorry, guys. 38.88 years for $985.32. It's going to be approximately 43.54 years. And for $24,582, it's going to be approximately 145.67 years. So you probably won't see that dividend in your lifetime. I will just say one more thing before I stop this video. I'm not going to do the last one for you, but I can help you set up the equation. If our initial investment, our principal investment, our P is $300, our percent is 1.2, which makes it 0.012, and our interest is compounded quarterly, what that means is it changes our exponent from being just t to being t divided by 4. So all that does is change our exponent, and that's going to be equal to $10,000. All right, good luck, and we will see you for the test.